When we want to have an innovative product, we need to work every day to make all the upgrades and adapt new technologies to get the best product performance possible. And that is what we have been doing in our drones and app in the last 2 years. In this second year, the Portuguese partners intended to visit almost all the AfarCloud scenario demonstrators. Due to COVID-19 restrictions, we were forced to adapt and to create a Portuguese test bed in 𝗕𝗲𝘆će. The main organizer of this test site was PDMFC.
In this testbed, the latest version of 𝗣𝗏 framework was tested. This drone framework was elaborated with AfarCloud requisites in mind, being optimal to pilot UAVs from a distance, remote control them, plan autonomous missions and monitor them. The data is transmitted to the AfarCloud and then it's possible to visualize via the Drone Web Terminal. The Drone Web Terminal is a cloud web UAV terminal that mimics a UAV radio command with the advantage that the pilot can control the UAV remotely throughout the internet. The pilot and UAV only need an internet connection to the platform. This is split into several blocks which have dedicated nodes. The drone or gazebo, if under simulation, are core pieces of this framework. They share a common controller interface that is agnostic of the communication, and the communication can be WebSockets, Direct Link or DDS. Pilot is always top priority. Afterwards, the dynamic collision avoidance algorithm is the second one with the most priority. Lastly, the static collision algorithm is the one with the lowest priority. In this second year, we focused on a collision avoidance algorithm that is capable to avoid a collision with a dynamic obstacle, such as an animal, or an incoming object, such as a thrown ball. For this, the UAV needs to detect them and execute a safe maneuver to avoid them. The higher the relative speed between the UAV and the incoming object, the more important the role of perception latency is. The solution we are working on is composed by two steps. The first is the feature extraction step, which retrieves features from a given frame by using convolution neural networks and store them into feature vectors. The second step handles the temporal information characteristic of videos by using the last 25 feature vectors and outputs a classification or a regression. The algorithm is capable of processing each of the frames in real time, estimating if there is a collision or not for that given moment.
To integrate all the UAVs in the platform, it was developed the Drone Web Terminal. It is a cloud-based platform that allows to control remotely UAVs. This platform has 5 main functionalities: communicate in real time with the UAVs, receiving telemetry and video, and transmitting commands. Meanwhile, the DDS is not completely ready. We utilize WebSockets. Actuate over these UAVs by giving planned missions with designated waypoints. Orchestrate a swarm mission with multiple UAVs. Collect and analyze the data produced by this UAV during a flight and possibility of replaying this data. Run artificial intelligence algorithms facilitating user decisions. Whenever an UAV is switched on, it tries to establish a connection to the platform using mobile communication. The mobile MMT is a visual app to support on-site decisions and monitorizations. The mobile MMT is a field extension of the main MMT. It is a mobile application for phones and for tablets that enables the user to visualize the context of its farm and to monitor its current status. This app has 7 main functionalities. Mission screen. Access the missions ongoing and the missions to come. The app connects to the middleware to show the user the mission information and the vehicles in it. The user is able to pause, resume or abort a mission if by any chance he feels to. Vehicle screen. In this screen the user can interact with available vehicles. Sensor screen. In this screen the user has access to the historical data collected by the sensors. Report screen. In this screen the user can access the total mixed ration calculator and the carbon footprint calculator.
We have been working on several points of the project, such as the middleware, communication by DDS with Technology, in the integration of RFID sensors in AfarCloud drones, in 2D and 3D processing multispectral maps with GPS information. To be possible to communicate the drones and the cloud, AfarCloud's project is working on DDS. Regarding the integration of RFID sensors with AfarCloud drones, due to COVID situation, it was not possible to work directly with partners in order to make a more robust and easier job to integrate. However, it will be possible to finalize this integration until September 2020.
In the Portuguese demo, we integrated our Austrian partner sensors in a demo that the UAV makes an autonomous mission that fetch the information from deployed sensors.